Hello everyone, this is me, Oscar from the Coding Universe, and in this episode I'll be teaching you about 4 rendering modes in OpenGL. Now you're probably asking yourself, why would I learn extra rendering modes in OpenGL? And the simple answer to that is, it's much faster. Okay. Now for this tutorial you need a minimum version of OpenGL 1.5 to use vertex buffer objects. You can get your OpenGL version by printing GL getString GL version after you created a display and then you destroy the display afterwards. You can download this program from my GitHub repository or from the description. So when I run this program, I can see that my OpenGL version is 2.1, which is high enough for all the rendering modes I'll be covering in this tutorial. Now, the first rendering mode I'll be covering is immediate mode. So I've created a class that renders a color triangle using this so-called immediate mode. Let's run it. So yeah, that's the colored triangle. Up until now, we've only been using immediate mode for OpenGL rendering, and you can identify immediate mode by looking at the GL begin and GL end clauses. By the way, GL rectf is also immediate mode. So one of the advantages of immediate mode is that it is very simple to understand. Also, you can modify the inputs in a really easy way. Now, one of the drawbacks of immediate mode is that it is slow. It is really slow. Once you go, for example, the 3D demo, which still used immediate mode, if you vastly increase the amount of points, you can see it really starts to lag, something that you can prevent using more advanced rendering modes. Also, it is outdated. It is very much outdated in OpenGL, and yeah, it's actually no longer supported in the newer versions of OpenGL. So now the code for this is really simple. You should really understand this because, well, we've been using this technique for 17 tutorials right now. All this stuff here is just standard, and the GL begin, GL end stuff draws a triangle using the 1111 orthographical presentation. So as you can see, we give a color for each vertex and do that. Yeah. So we specify the vertices and then OpenGL creates a shape. Now let's go to the second rendering mode, display lists. So I'm going to run this example, and again you see the triangle, the colored triangle. Just as with the immediate mode, it's actually exactly the same triangle. And because it's only one triangle, you can't really see performance upgrades or performance increases, because it's only one triangle. So, now in display lists, they have a few advantages. For one, they are much faster than immediate mode rendering, and they're also one of the fastest rendering modes available now in OpenGL. One of the drawbacks is that you can't modify the data you've sent to a display list, and also it as well is outdated, unfortunately. The code for this is a bit more unfamiliar than the previous code, but it still looks very familiar. The first thing we do after we've initialized the display is create a new integer called displayListHandle, and we assign that to GLGenLists1. This will always be 1 if you use it like this. Then the second step is to call GLNewList. The first parameter will be the displayListHandle, so we'll enter our displayListHandle, and the second parameter will be what OpenGL has to do when you're done entering the list. In this case, we'll just compile, so GL compile. You can see this as some kind of GL begin clause where you start entering or start the display list. And when you're done entering commands into the display list, you can simply say GL end list. Now in this display list, you can simply copy the code we created in the immediate mode demo, and when you call, this is not display lists, when you call GL end list, this will be precompiled in OpenGL so that it can be accessed really fast. And you can access the display list or run the display list by calling GL call list and then the display list. After you're done with the display lists, you can do GL delete lists. And then the first parameter will be again your display list handle, and the second parameter will be 1. This is important so OpenGL knows it can clean up the display list because it knows for sure you won't be using it again. So that's everything for display lists. Let's head over to the third rendering mode. So if you run it, we still see it draws a colored triangle just as with all the other rendering modes, actually 2 so far. And let's stop here and talk about vertex arrays. So one of the pros of vertex arrays are that they are much faster than immediate mode. And you can also modify the data on the fly with vertex arrays. The data is stored on the client side, meaning you can access it from your Java program without calling OpenGL functions. Now one of the cons of vertex arrays is that it is not as fast as display lists. And again, vertex arrays aren't too depreciated. Now, the final, or actually, I'm going over the code first. Yeah. The most difficult code up until now, it's difficult. So let's go through it bit by bit. Here you have the standard initialization code, and then we have these 3 variables. Amount of vertices, which indicates your amount of vertices. And I believe this could actually just be 3. So yeah, we have 3 vertices. Let's see if it still runs. Yeah, it still does. And then we have our vertex size, which is the amount of components in our vertex. So x, y, z would be 3 vertex size, x, y would only be 2 vertex size. And then we have our color size, which does the same but for colors. Now here's a new thing, the float buffer. You can look at it as a very complex array of floats, because that's what it is actually. So float buffer vertex data is bufferutils.create float buffer, and then the amount of vertices times the vertex size. So we basically allocate 3 times 2 is 6 places in the vertex data. We can put vertex data in, or floats. Now bear in mind that this is actually a fixed storage. You can't say, oh, now I'm going to increase the capacity for the float buffer by 10. No, you can't do that. It's just fixed. Once you declare it here, you're done. So here we put the vertex data in the form of a float array by using the put method in the float buffer. And the vertices will be exactly the same as here. Minus 0.5, minus 0.5, 0.5, minus 0.5, 0.5, 0.5. If I were to modify one of these, for example put 1 in here, you would see that in the program. Yeah. Okay, let's go back. Once we're done entering all the floats, we can call the flip method, which basically makes it readable for OpenGL. Now, since we only have the vertices, we also want the colors, of course, because, well, we want a colored triangle. So we are going to create another float buffer called color data. And this float buffer will actually contain or be exactly the same as the vertex data buffer, except it uses color size and the color vertices. So this will just be the stuff you pass in through the GL color 3F 10001110001. Yeah, it's the same. So again, if I were to put the first color vertice to white, you can see that here it's white. And then I call the flip method so that it makes, again, the float buffer readable for OpenGL. Now let's go into the main display loop, and this is a lot more code than with display lists, as you can see. So yeah, we're going to enable vertex array and color array so we can use vertex arrays. It's one of the prerequisites for using vertex arrays. So we do that, and then we call GL vertex pointer 2, which is actually just the vertex size, 0. Yeah, you can leave that at 0, and then vertex data, which points to our float buffer of vertex data. And then we have GL color pointer 3, which is, yeah, the color size, 0, which you can leave 0. And then color data, which is the float buffer that contains all the color vertices. Now, when we're done with this, we can call GL draw arrays, which actually draws the stuff on the screen. Because up until now, we've only said to OpenGL, you can find our data there and there. And now we're going to say to OpenGL, we're going to draw it like this. So we draw arrays, and the first will be the type you also indicate with GL begin. So in this case, GL triangles. The second one is the first, which will be 0 right now. And the third parameter is the amount of vertices, which we've already specified here, so 3 vertices. Yeah. Okay. That's everything for vertex arrays. And now the most challenging rendering mode, vertex buffer objects. For this you need a separate static import for org.LWJGL.OpenGL.gl15, which stands for all the functions housing within OpenGL 1.5. So again, all this initialization code will be the same, and the initialization code for vertex buffer objects is actually really similar to the vertex array initialization code. In fact, you can copy these float buffers right into the vertex array buffer demo. These will stay the same. The only difference is how we give it to OpenGL, and that we use vertex buffer object handles to do this. So the first thing we want to do is create a new vertex buffer object handle for the vertices. And we do that by creating an integer called VBO vertex handle and assign that to the value returned by glgen buffers. And once we have that handle, we have to bind it. So say OpenGL, you'll have to use this buffer for all upcoming buffer uses or method calls. So we're going to use GL bind buffer, and the first parameter will be GL array buffer. That's the type we need for vertex buffer objects. And then the second parameter will be the handle to our vertex buffer object. Now here we have GL buffer data, which basically stores the data we have in our float buffer to the vertex buffer object. Now you can look at this as a vertex buffer object is a piece of memory on your graphics card. And that piece of memory you can access by using GL buffer data, and you can use to draw by using the GL vertex pointer, then GL draw arrays. So yeah, that's how we can use it as, that's how vertex buffer objects work. And this method, GL buffer data, stores the data. The first type will again be GL array buffer. The second type will be the data we want to store in the VBO, in this case vertex data. And the third will be our render preference. So these render preferences you can find in the OpenGL documentation. I'm not going to go through all of them right now, and you can do that by yourself. So now we already have one VBO separate for the vertices, and we also want a VBO for the colors. So we're going to repeat these same steps, and the only difference is that we're going to use color data and call the handle VBO color handle. Also, when we're done with buffer data, we say GL bind buffer GL array buffer 0. So we bind the buffer to 0, meaning, we unbind the buffer, so we aren't using VBOs anymore. If you want to use vertex arrays in conjunction with VBOs, this is a must. If you don't do this, it will throw a GL checks exception, saying you can't possibly use vertex arrays at the same time when a vertex buffer object is enabled. So that's everything for the initialization code. Now for actually telling OpenGL where to look for the vertices and the colors. Again, we're going to bind the buffer of our vertex VBO, and then we're going to call GL vertex pointer, the first one being the vertex size, the second one being the type of data, in this case GL float. The third is the stride, which you don't have to worry about. And the last one is the offset. You can experiment with offsets by, for example, putting color in a vertex buffer object. So but I'm not going to cover that in this tutorial. And now we're going to go to the GL bind buffer array buffer color handle. So now we're going to let OpenGL point to the color data. So GL color pointer 3, which is the color size, and then the type, which will be GL float, the stride, which will be 0, and the offset, which will also be 0. The offsets are 0 because, we start at the start of the VBO for pointing to our information. Now to draw the arrays, we do the same as with vertex arrays. We enable the client state vertex array and color array, and then we call GL draw arrays, GL triangles, and then here the amount of vertices. Amount of vertices, and this should of course be 3. Yeah, it is. Okay. So if I run this, you can see the color triangle, just as with the vertex arrays, display lists, and immediate mode. And while we're here, I'm going to tell you why you should use vertex buffer objects. Now, the first and foremost reason is that they are fast. In some occasions they might be a bit slower than display list, but if you have a strong graphics card, these will outperform any other rendering mode in OpenGL. The second is that you can dynamically modify the data in the VBOs. You can do this by using the methods GL buffer data or even GL buffer subdata. This is also a non-depreciated way of drawing stuff in OpenGL. It is not outdated. People still use this method in the newest OpenGL versions. Now, one of the drawbacks of vertex buffer objects is that they are really hard to set up. As you can see, this code is very error prone. If you, for example, misspell the size of the vertices or something like that, everything will mess up. You'll get all these weird errors and just nasty stuff. You can't really debug this either. It's just, you have to look at it and you have to be sure that this works, and if it doesn't, you're screwed. Also, when we're done with the buffers, we delete them by calling GL delete buffers, and I just realized I didn't delete the color buffer. So now, I deleted the color buffer. Sorry for that. Now hopefully you should have an understanding of all the different rendering modes in OpenGL I taught you today, and you might even be able to implement this in your own project. So a quick summary: don't use immediate mode, it's slow, it's fine for demonstration purposes, but for the rest just stay clear of it. Use display list if you want static geometry that can't be modified later on, for example, backgrounds, because they're much faster than immediate mode. And then when choosing between vertex arrays and vertex buffer objects, the only real reason you would go for vertex arrays is maybe if vertex buffer objects aren't supported on your system. So you usually just want to use vertex buffer objects. Now I've also put together an example that takes the 3D demo class we created in episode 15 and modifies it in a way so you have all the different render modes. And you can switch between them by pressing the 1, 2, 3, and 4 keys. I'll show it to you right now. So I've added a bit more points, so it's a bit more CPU intensive. And you can see this is immediate mode, it's slow, it's sluggish, you don't want this. And then we have display lists, which are much smoother. Vertex arrays, which appear to be the smoothest. And then vertex buffer objects, which are roughly as smooth as vertex arrays, maybe a bit slower. This brings me to another conclusion. Vertex buffer objects use the graphics card. So if the graphics card is really busy, for example when you're recording a screen like I am, it's probably best to use vertex arrays and display lists in favor of vertex buffer objects because, yeah, they're just faster then, because the processor might not be as busy with stuff as the graphics card. So yeah. This was Oscar from the Coding Universe. I really hoped you liked this tutorial, and bye.